Hello, this video is about SHAB, that is soft hard acid base theory. Let's look into the principle of HSAB. Now the basic principle is that the hard acids prefer binding to the hard bases to give ionic complexes, whereas soft acids prefer binding with soft bases to give covalent complexes. The large electron negativity difference between the hard acid and hard base give rise to strong ionic interactions. And likewise, the electron negativities of soft acids and soft base are almost the same, hence have less ionic interactions. That is, the interaction between them are more covalent. So the interaction between hard acid and soft base or soft acid and hard base are mostly polar covalent and tend to be more reactive or less stable. The polar covalent compounds readily form either more ionic or more covalent compounds if they are allowed to react. Now let us look into some applications of this principle. First we have the recovery of Au. Now the softest metal ion, that is Au plus aqueous, is recovered in mining operations by subtending it into dilute solutions of Cn minus, which basically dissolves with the Au. So we can use this principle to find the to recover the Au, like Au solid plus Cn aqueous plus O2 and H2O would make AuCN2, that would be aqueous, and OH minus. Then we have in hydrogen bondings. So the strong hydrogen bond is possible in cases of H2O, NH3 and HF. Now since the donor atom, that is F, O and N, are hard bases and the interactions with particularly positively charged H, which is hard acids, are stronger. Now coming to precipitation reactions. So the softer acids that are like Ag plus, Hg plus or Hg2 plus, etc. And the borderline acids like Fe2 plus, Ni2 plus, Cu2 plus, Zn2 plus or Pb2 plus, etc. can be precipitated as sulfides from their aqueous solutions, since the S2 ion that is present in them is a softer base. But what we should note is that Ca2 plus and Mg2 plus are the hard acids that appear as carbonates, that is CaCO3 and MgCO3, right? Now let's look at some examples. So let's first look into hard acids and soft acids. Now what are the differences? Now hard acids are have small ionic radii. Now ionic radii is basically the distance between the nucleus till the last electron that is present in the orbital. That is the ionic radii of an atom. So hard acids have small ionic radii, whereas soft acids will have larger ionic radii. Now hard acids have high positive charge, whereas soft acids would have lower positive charge. Hard acids are strongly solvated. They have empty orbitals in the valence shell and are high in energy. Whereas in soft acids, they are completely filled atomic orbitals, which is also a reason why it has lower positive charges and it has low energy. Now examples of hard acids would be H plus, Li plus, Na plus, K plus, Be2 plus, Mg2 plus, Ca2 plus, Sr2 plus, Sn2 plus, etc. that I have listed down. And soft acids would be Cu plus, Ag plus, Au plus, Hg plus, etc. Now moving to hard bases and soft bases. Now hard base you would find it is very similar to the hard acid properties, right? That is the hard bases have a smaller ionic radii, but it has high electron negativity. It is weakly polarizable, strongly solvated, and high energy. Out of these, the small ionic radii, strongly solvated and high energy, would be common with the hard acid part. And similarly in the soft base part, We have the opposite, which is similar to the soft acids, that is large ionic radii, intermediate electron negativity, and high polarizable and low energy. Now, some examples of hard bases would be H2O or Fe minus, Cl minus, PO4, 3 minus, etc. And soft bases would be Cn minus, SCN minus, or CO, C2, H4, or C6H6. Now that is it for this video on the principle of soft and hard acid and base. Thank you.